Number 35, which I'm not sure if that's the one you were actually asking for, but the easiest way to do a problem like this is to use the trig identities and convert tangent squared y plus 1 into secant squared. So just kind of going back over our identities, since it's been a while for several, we know that cosine squared plus sine squared is equal to 1. And if I divide both sides by cosine squared, I get 1 plus tangent squared is equal to 1 over cosine squared is secant squared. So this actually just becomes the integral of secant squared, and the integral of secant squared dy, and the integral of secant squared is tangent. So this just becomes tangent of, I should say y's, tangent of y plus a constant. And then just kind of verify if you go in the reverse direction, the derivative of tangent is secant squared. I think you might have been asking about number 34, since that looks a little bit more like sine squared, secant squared, but let's multiply it anyway. So if I multiply this out, I get secant of y tangent of y minus secant squared of y. And there's no amount of trig combinations that are going to make this easier. Well, for now, but what we know is that the integral of secant tangent, that is the derivative of secant of y, because the derivative of secant is secant tangent. And then the derivative of, or the integral of secant squared, just like right up above, is tangent. So this just becomes secant y minus tangent y, then plus c. So that's it.